All right, this is an introduction to couplings and shaft alignment. All right, so let's first talk about couplings and what it means and why we need to use them. First thing is that generally speaking, there is going to be a motor of some sort as a prime mover in any kind of a system that is taking electricity and creating rotational forces, and that needs to be coupled to something. It's going to be driving something, moving something, and there are many different ways to attach a motor to some kind of an output shaft or a working device. So let's talk about a few of those things. A few of the ones that we have are here. A Lovejoy coupling. Okay, as you can see, it has a space for a shaft here and shaft here, and it has 3 drive dogs with a piece of essentially rubber or plastic in between, and this allows for some misalignment. Okay, so you can be a little bit off and you can still drive a shaft with a motor with this. We also have something like a grid coupling, and as you can see here with a little bit of movement, it allows for some angular distortion between output shaft and motor shaft. A couple other examples include a gear style drive. There's actually a bit of a sphere here or a radius to allow angular misalignment, okay? And then of course the most common for allowing angular misalignment is a universal joint, okay? But let's say that we don't have that option, we have some other constraints. Then you will find different items like this right here. This is a solid shaft coupling. Okay, so a shaft goes in this side and a shaft goes in this side, but wait a second, there's no room for flex. There's no room for angular or linear offset with this particular style. Also, too, something along these lines is a flange coupling, okay? So you have 2 flanges here that actually need to bolt together, so they actually need to be in line like this, and they need to be in line like this, and they need to be in line like this. So all of those things need to be perfect in order for these 2 things to bolt together and have that motor drive that output. So we have another example right over here that is a flange coupling style. So if we use a flange coupling, how in the world do we get an input to match the output? Well, there's a few tools that we use for that, one of which is something as simple as a ruler here. Okay, we use a ruler for a couple reasons. We want to take measurements, but then we also want to use this as a straight edge, and we can line that straight edge up in between these 2 devices here, and we can see the differences. So if this is sitting flat on this flange and it's not on the other flange, then we know that there's a discrepancy. And then if we want to know how much that discrepancy is, if we want to measure a gap, then we can actually take these here, these feeler gauges, and they are very, very, very thin to very thick, and it actually has on them what the thickness is. So as you slide those in, you can get an idea of how much the shaft is misaligned. Now this right here is a rough measuring system. Now when we get a little bit finer, we're going to be using things like dial indicators. Okay, this one right here has a coupling so that it can fit onto a shaft and it can rotate around and give us some very close and fine measurements. There are other styles like we have here with a magnetic base, but all of which are the same. This is supposed to be mounted rigid, and then this here goes up against what you want to measure in relationship to what this is sitting on, and then as this moves, it gives you a direct reading for how far something is off. Every single one of those lines is worth 0.001 of an inch, and that's expressed as 1/1000. So we're going to use these tools in conjunction to be able to line these shafts up. But again, there's not just one way that a shaft can be out of alignment or have a misalignment. There are many different ways. We can have a height difference, we can have angle differences, and so on. So through the next several videos, we're going to be talking about how to get those things lined up. A few other little things here. We figure out how far things are off, but then when we need to get them in line, oftentimes we're going to go to something like this little kit here. These are shims, and they have a specific thickness to them. We'll learn how to calculate how much shim to put in there in order to get the desired result. Also, too, you'll notice here, it may be hard to see, but there are some jack screws that will allow us to move this motor back and forth. So between the shimming and also adjustments built into the system, we're going to use those to make our adjustments predicated on what we learn from our indicators as we set those up. Okay, so another little tool here that we'll talk about. It is going to get a little interesting when we start rotating indicators around. yes, it sounds pretty simple, but we have a mirror here, so as we're reading on top, we can see it. But as that dial rotates around underneath, we'll be able to use a mirror to take a look at those things. Again, all just some simple tools to kind of learn how we transmit power from motors to outputs, and then of course a little bit of the differences with those, and then really what I want to do is talk about when you have to have a rigid coupling, how do we align those shafts. That'll be the next video.